We have taken the additive property, constitutive property and colligative property. We got the details about the colligative property in the last lecture. Earlier to that, we have taken dipole moment. So when we have taken the dipole moment, at that time only you came to know that dipole moment is associated with polar molecule, and what the polar molecule is, that you know it very well. There is a difference between polar molecule and non-polar molecule. We are interested in polar molecule, especially when it is a solvent. There are polar molecule who are solute also, who are drug. Now why we need the polar molecule? That also we have discussed. Polar molecule encourage dissolution. Polar molecule encourage solubility of drug. Polar molecule, because it is giving the good solubility of drug, we know that for the absorption of drug from the stomach or from the small intestine, what we need, basic need is our drug solution. Without having the drug solution at the site of absorption, no drug is going to enter inside the blood circulation. Means bioavailability will not take place if your drug do not get dissolved either in the stomach or in the small intestine. So I am repeating it several times, and in each of my lecture I am always repeating this statement to show the activity by any of the drug. What we need? We need the drug should be in blood circulation. Means the drug should be bioavailable. And how the drug will get bioavailable? It will get bioavailable only when the drug will be in the solution form at the site of absorption. Site of absorption is different. Site of administration is different. Site of administration of drug is mouth. We are talking about the oral. We will not talk about the other thing, other dosage form or other route of administration just now. We are talking about the oral. Mouth is our site of administration. Stomach is our site of absorption. Small intestine is our site of absorption, from where drug is going to get absorbed into the blood circulation. Again, I am repeating the statement. For the absorption of drug, what we need the drug, all drug should get solubilized. If the 100 milligram drug is there, reaches the stomach and 60% only get dissolved, then there may be chances that 60% drug only will get entered into the blood circulation. 40% not get dissolved, it will not get entered. Is it clear to all of you? Is it clear to all of you? And I am seeing that the number of students got reduced. Earlier it was 85 plus something. Now it is a 65 plus only. Why? You want to learn chemistry only? You don't want PP? So tell me, those who will remain absent, you don't want PP, I will not allow you to enter my class. Never. If you don't want. Okay, let it be. So, convey my message to others also, those who want to remain absent. Convey it to your friends, your colleagues. Okay, so we want the drug should get solubilized. That is our center point. We learn about the dipole moment. Dipole moment is a property of polar compound. Dipole moment. Polar molecule. Polar molecule, through its polarity, means the charge separation in a molecule, partial positive, partial negative. Polar thing, polar molecule is there. Polar molecule is there. Okay, so this polar molecule, all the polar molecule help to get more solubility for the drug. More solubility of the drug can be occur by the help of polar molecule. Non-polar molecule not having the capability to enhance the solubility. This thing you have to keep in mind. The polar molecule is having dipole moment. Polar molecule is having polar nature. Now the question will come, how we can measure the polarity of a molecule. Polarity of a polar molecule or polarity of a non-polar molecule, whatever. Polarity will be our focusing point there. How we can measure? So that by doing that, we can take that particular solvent who is having good polarizability, who is having good polarity, that we can easily sort it, that we can easily and quickly can be taken, and then that can be used as a solvent to dissolve the drug. That is our target. What we want the drug solubilization. What we want, the drug should get dissolved. That is our main center point. And for that only we are doing all these things. We are going in depth about physical properties of drug molecule by keeping our thread from the drug solubilization up to the dielectric constant now. Dipole moment and dielectric constant. So here what we want the drug should get solubilized. It will get done by the polar compound. Dipole moment will be the responsible factor for that, but the measurable factor, measurable property of that polarizability or dipole moment or polar nature is dielectric constant. It is a tool. It is a tool. It is an electrical tool. It is an electrical tool. I already told. I already given the example. Mass cannot be measured. My body mass cannot be measured. But I can measure the weight through an electronic device. That is a weighing machine. So that becomes a tool for measuring my mass. Weight becomes a tool. Weighing machine becomes a tool to measure my mass. Similarly, to measure the polarizability, we want the dielectric constant should be there. And dielectric constant give us the particular thing. Okay, now today we will see what dielectric constant is. So let us see what exactly dielectric constant is. I have shared a book of Hazare in your group, so you can have a look of that. Can you able to see this? Okay. Can you able to see this?
Yes, sir.
Yeah.
Yes, sir.
So as you can see over here, molecular dipoles are of three types. Before going towards the dielectric constant, we must learn about these three things. Permanent dipole. These occurs when two atoms in a molecule have substantially different electronegativity, with one atom attracting electrons more than another, becoming more electronegative, while other atom becomes more electropositive. Earlier we have taken several examples of that, in which one is highly electronegative atom, whereas the other one is electropositive, contained with less electron, so that towards the electronegative atom more electron will be there, towards the electropositive atom less electron will be there, and this molecule we can say it is having a permanent dipole molecule. I think you got this point very clearly. Next point, instantaneous dipoles. Instantaneous, instantly, name itself suggesting the meaning. These occur due to chance, when electrons happen to be more concentrated in one place than another in a molecule, creating a temporary dipole. So first one is permanent, second one is temporary. Okay. Such kinds of things of instantaneous dipole may occur endogenously, means due to influence of its own structure, okay, or it may occur when the particular molecule come in a particular vicinity. Vicinity means in that location. That is called the, and due to that,
Icon.
एक minute. Due to that, why the mic is getting off several times? Am I audible?
Yes, sir.
Yeah.
Yes.
So,
Yes, sir.
instantaneous dipole, instantly dipolar nature get created in that molecule due to several factors. Second one is instantaneous, but it is temporary. Keep in mind, once the molecule moves away from that vicinity, from that location, its dipolar nature may lost by that molecule. So this is the permanent dipole and instantaneous dipole. Next one, induced dipole. Induce means someone is enhancing it. Someone is inducing it. Enhancing, inducing. Someone is there which enhance, which induce, which produce the dipolar nature in the molecule. This occurs when one molecule with a permanent dipole repels another molecule's electrons, inducing a dipole moment in that molecule. So how you can understand this? When a molecule which don't have the dipolar nature, it is normal. But when it comes in, or when we put that molecule which don't have any dipolar nature, which don't have any dipole moment, when we put it inside a solvent, say water, and water is having a big dipole moment, all the water molecules are dipolar in nature, so that when this non-polar molecule comes in the vicinity of polar molecule, just like the water, the polarizability of the non-polar molecule also get induced, also get increased, also get produced, so that we can say that water induces the dipolar nature in that normal or non-polar molecule. So this is happening. This is happening. So what is happening in that case? As we know that water is having charge separation in its molecule, in its every molecule. Plus charge towards one side, minus charge towards another side. We have seen that from the diagram. Plus charge will be that region of a water molecule which is having less electron. Minus charge will be that region of water molecule which is having more electron. Now imagine all the water molecules are there in a beaker, and we have placed such a non-polar molecule which don't have any charge separated region in its molecule. So what will happen when it comes in the vicinity of polar molecule just like the water? Then it also start to behave in accordance with water molecule, in accordance with dipolar molecule. So what is happening with polar molecule then? Negative region, listen, negative region of a non-polar molecule will get aligned with the positive region of polar molecule, like water. Again I am repeating, negative region means the negative phase, negative region, negative phase of non-polar molecule will get aligned. Align म्हणजे काय? Just it would be nearby to it will get aligned towards the positive region of the water. And similarly, for the second molecule of non-polar compound, positive region of it will get aligned with the negative region of the polar molecule. Understood? Yes or no? Understood? Yes or no? So it is very, very simple. The non-polar molecule which came in the vicinity of water will align themselves because they got the induced dipole in them. They also got the charge separation somehow. Okay? Because they came in the vicinity of the polar molecule. So this is called the induced dipole. Example is induced dipole. And we want it because water through its dipolar nature, through its induced dipole behavior, further increasing the solubility of such kind of non-polar solute. And what we want earlier, we want that only. Earlier only I told what I want, what we want as a formulating people. We want increase solubility. We want more solubility, and that will get done by water very nicely through induced dipole, through its induced dipole behavior. I hope you got the good understanding and you are stuck with our target. I am not leaving my target behind. I am always recalling it. That is our target. My target is water solubility, either in stomach or in beaker or in small intestine. That is my target because I am a formulator. No matter I am learning the PP, no matter I am learning the POC, no matter I am learning the engineering, my target is fixed. I am a formulator. Got it? Keep your thread over there. Okay? Knotted over there, and then take away the thread with you so that the proper correlation will get existed, will get created in your mind. Proper correlation. Okay? Proper correlation, so that induced dipole is this phenomena. So I hope you got the clear understanding now of permanent dipole, instantaneous dipole and induced dipole. Okay, and all these are being associated with the dipole moment. Now we are shifting ourselves towards dielectric constant. Dielectric constant. Okay, dielectric constant. I already told that dielectric constant is a measurable tool, as you can see from this table. Just have a look onto this table. See the water where it is and see the dielectric constant value of the water. Dielectric constant of value of water is 80. Highest means, first of all, we will exit the correlation. Dielectric constant highest means.
Sir, you are not audible.
Am I audible now? Am I audible?
Yes, sir.
No?
Yes, sir.
एक minute. Now, am I audible?
Yes, sir.
Yeah. Quickly you should tell me, because I am recording the lecture so that it may get wasted there. Okay. So, be with me. Have a look onto all this value. Be fast. Fixed oil, zero dipole moment, zero dielectric constant, not having the capability to solubilize other solute, whereas water having highest capacity to solubilize other solute. It may be drug, it may be any chemical compound. That is a correlation I want to place in your mind. So what is the correlation that is existed? Water is having highest dielectric constant. Means what? Water is more polar molecule. Very clear, very simple. From the dielectric constant value, anybody can guess who is having more dipolar nature, who is having polar nature, who is having the capability to get induced dipolarization, who is having the capability to get instantaneous polarizability, who is having the capability to get permanent dipole. Water is a permanent dipolar molecule, whereas the rest of the molecules may have permanent or instantaneous or induced polarizability. Others can be get categorized in these three. So very simple. More the dielectric constant value, more will be polarizability, more will be solubilization capability. Got it? So this is the main concern that we got. Now we got the dielectric constant in total. हमको ये मिल गया है, अभी डाइलेक्ट्रिक कांस्टेंट को आपको पता चल गया है कि हाउ डाइलेक्ट्रिक कांस्टेंट इज वेरी डाइलेक्ट्रिक कांस्टेंट वैल्यू इज वेरी यूजफुल फॉर अस. From the dielectric constant value we can easily guess who is having the polarizability, means in simple word who is having the more solubilization capacity. Very simple. Now we will see what is the basic to get that value, what is the mechanism, what is the mode, what is the principle to get that value. How they got that value? They got that value through an electronic instrument by using this principle or by using this concept. Okay, very simple concept it is. Are you understanding? Are you understanding what I taught? Hello? Somebody should reply fast. Are you getting all the points what I am trying to say?
Yes, sir.
Yeah. So now I am going to tell how we can get that value. Okay, we can get the dielectric constant value. Very simple. As you can see, it is a parallel plate condenser. Parallel plate condenser means it is simply an electronic device which we are saying that it is a capacitor. Capacitor are there which having the capability to show the capacity by which the electric field can be stored. Very simple. Just imagine that it is a simple device of electronic which showing the capacity to hold the electric current. Very simple. As you can see, it is a voltage source and this is a battery, you can say in simple. Battery is always having anode and cathode. Two ends are always there. Very simple. It got connected, these two plates got connected with the voltage source, means your plug, you can say. These two plates are away from each other through a certain distance. Okay, and what we have done, we have inserted, we have filled, we have placed the sample in between these two plates only. That's it. Sample. Here our sample may be water. Very simple. Huh? Try to understand. Concept is very simple. Water is in between them. Okay. Now water being polar in nature, everybody knows. Water will be there in between these two plates. Okay. Now we will switch on the voltage source. Switch on the button. Now you will find that current will flow from positive terminal of the battery toward the negative terminal of the battery. Current, again I am repeating, current flows from positive terminal to the negative terminal, and while flowing through, so that the circuit would get completed. Everybody knows about the circuit. We have learned it in 8th standard only, and then 10th standard also, and 12th standard में तो बहुत ही ज़्यादा था. Got it? So in this way circuit will get completed. Circuit will get completed. While completing this circuit, you will notice that water is there. Water is there, and water is having polar nature. See over here, these are all water molecule having charge separation charge separated region in its every molecule, positive side and negative side, positive side, negative side. This is in positive side, negative side. This one is different, huh? This one is change state, you can say. Earlier water will be there. As soon as we switch on the electric current, the current passes through it and passes through water also, and they got the good alignment like this. Originally it would be like this, then as soon as the current opens, it would change. This is called a polarized molecule. But what is happening with the water? Earlier only it is polarized. Originally only it is polarized. Water originally only being polarized molecule. So that very quickly the alignment, this kinds of alignment for all the water molecule we will get very quickly. Okay, means that from that we can guess that the water is highly polarized molecule. Now read this. The ease with which a molecule is polarized by any external force, it may be electric field, light or any other molecule, is known as polarizability. As here you can easily see that originally only water is being polarized. So with very ease, instantly water molecule would acquire these polarized state. Very ease. Means what we can conclude with water is highly polarized. Water is highly polarized, so that by doing some calculation we are getting this value as 80.4, because water is highly polarized. Okay, so this is the base of this concept. Now next, remove the water, place some another non-polar molecule or less polar molecule. Now here in the diagram it is being shown. Originally the molecule will be like this, non-polar. Switch is off now. Switch of this capacitance or condenser or battery is off now, so that the original state of the non-polar molecule will be like this, or the less polar molecule will be like this. No charge separation in the molecule. As soon as we switch on the capacitance, they would change themselves like this with a particular degree, not with the same degree, with a particular degree. Okay, but while doing so they are consuming more current. To get this state, to get this polarized state, more current. So can we say that with very ease, the polarizability will occur in non-polar molecule? Can we say with very ease it is happening? We can say it is not happening with very ease, just like the water. Some sort of work needed to be done by the electric field to get the polarizability of all the molecule of that sample. Okay, with certain effort by consuming certain electric current, then only the non-polar molecule will get transfer or change like this orientation. These are the orientation, because some sort of work done will get done inside the molecule, because there will be the existence of charge separation in every molecule. It will take some time. It will get done when the when electric field will get applied. Okay, so such kind of, in such cases we can say polarizability is not too much high, is not too much high, so that its dielectric constant value may be less. You can say, take the example of acetone, take the example of formaldehyde. They are not having so much dipolar nature, just like the water. Some sort of efforts needed to be taken by the electric field, okay, by the capacitance, to attain that polarizability for all the molecules of that particular sample. Here in this case, for the carbon tetrachloride, more efforts need to be taken, more electrical consumption, you can say, will have to apply. Okay, and on the basis of these, we got all this value for all the solvents. Mostly they are the solvent. We are interested in solvent only, because solvents only can make our drug molecules solubilize. I am again came to that main center point. What we want drug should get converted into solution, and solvent is the main agent which is doing that for us. Okay, concentrate on these bracket words. Polarizability can get change or increase either by placing the molecule in the electric field, or by light also, or by placing the molecule, non-polar molecule, in the vicinity of polar molecule. Keep in mind, all these factors are responsible for induced polarization in non-polar molecule. I hope everyone is understanding this very clearly. If you are having any doubt, then just let me know, so that I can go ahead. Very simple assembly is there. Yes or no? You must tell something here. Quickly you have to tell something, whether you are getting or not. Those who got, it is their duty, na, that they should tell me at least. Yes sir, I got it. Yes. Yes, have you got that? What I taught just now? Hello? Am I audible?
Yes, sir.
So you
Yes, sir.
all people must tell me when I am appealing to you in my first instance. Have you got? Quickly switch on the mic and tell me, yes sir. Okay. So I'll lose my continuation, na? To help me in that, please. So this is the dielectric constant. This is a practical way that we are doing. Okay. Now let us move ahead. Here you can see one formula. C is equal to Q upon V. C is the capacitance of a condenser. C is the capacitance of condenser. V is the volts, source of light, and Q is the electrical charge. Okay, so C is equal to, capacitance is equal to Q upon V. That will be our basic formula. Okay, now move on to the next. Epsilon in the top 2.44. Epsilon is equal to Cx upon C naught. Cx upon C naught. Okay. This C is the capacitance that we are getting from the first formula which I told. This is our first formula. C is equal to Q upon V. C is equal to Q upon V. First formula. So what we are doing over here, these are the two formula. C is equal to Q upon V. C is the capacitance of this battery when we will place water. Then we will check its charge. Then we will see their volt during the first experimentation. So that by doing so, we will get the C of capacitance of water. Capacitance of water. Capacitance of water. So C we got. Okay. By placing the water in between two plates, we got the C. Now what can be done further? Let us move on to the next formula. So we got that Cx. Cx means it is the capacitance of our sample that we have placed. We got the Cx. Here it is in this case it is water. Cx we got. Cx is equal to Q upon V. In this manner we got the Cx. Now remove the water. Keep the vacuum over there. Now see, switch on the source of light, source of battery. Now see how much is the capacitance of that battery when vacuum will be there, and that is called C naught. When vacuum will be there, capacitance of battery will be C naught. When sample will be there, capacitance of the battery will be Cx. Divide them and then you will get the epsilon. Epsilon, it is the symbol of dielectric constant. Epsilon, where E is the dielectric constant, and since it is a ratio of capacitance of the sample divided by capacitance of vacuum, so that it is a ratio of the same thing. It is the unitless quantity. It don't have any unit. It is having symbol only. Is it clear to all of you? The things are getting clear?
Yes, sir.
Good. I am waiting for you, whether you are following my instruction which I have given few minutes back or not. Luckily, you have given that. Okay. So, in total, I want to conclude the dielectric constant. The value that we are getting for water is 80.4. It is nothing but the epsilon of water. 9.7 is the epsilon of phenol. 22 is the epsilon for formaldehyde, and likewise for the others. So this is all about the dielectric constant. Dielectric constant we are getting by taking the ratio or finding the ratio of capacitance of sample divided by capacitance of vacuum. Reverse. Capacitance of the sample we are getting by placing the sample in a capacitance, applying the certain voltage and finding the charge on it, and then in this way you will get the capacitance for sample. When nothing will be there in between two plates, vacuum is there, we will get the capacitance of vacuum. Every time we don't want to find the capacitance of vacuum. One time only we can find out. and then we can find out the dielectric constant, that is the capacitance of sample for different sample by placing the different sample in between the two plates. Very easy. Change the sample, find the capacitance. Change the sample, find the capacitance. Place it in the numerator and you will get the epsilon, and that epsilon is the epsilon for that sample. Very simple. If you are paying the attention to my lecture, very simple. And that is the dielectric constant. It doesn't have any unit, it is having the symbol only. Got it? I have shared a book of this PCI syllabus. You will get that. This only I am sharing with this screen. Okay? So you should have a reading of that at least for one time. You should have the reading of that dipole moment, induced dipole, permanent dipole, instantaneous dipole, all these things. You must have the reading of that chart, table, all these things, so that you are, and very important, which I have highlighted over here, this line is of highest importance, because if anybody asks you what you are getting with the dielectric constant, straightway you should answer it is a polarizability, extent of polarizability about that sample which we have placed in the capacitor. Got it? So this is all about the dielectric constant, and it is the highly important tool for the research work when you have to check the solubility, when you need to check the solubility of your drug in multiple type of solvent. Every time you cannot spend your mechanical efforts, your work, by checking the solubility every time with all the sample, one time with one solvent, second time with, this will consume your efforts, this will tire you, at the same time you will consume all the sample, all the drug sample, all the solvent unnecessarily. But if you will straightway go to the literature survey and find the dielectric constant value for all the sample that you are about to do the experimentation, straightway you can take out that. Take out one or two sample, very simple, and you will get the desirable solubility of your drug. Earlier to that, you must also find whether your drug will have the polarizability, dipolar nature or something like that in itself or not. Means you need to find out the physico-chemical property of your drug sample first. Physico-chemical property. Got it? So I hope these are all research tool. These all are research tool. You will be get applicable, helpful whenever you will start your research. And next year only onwards only you are about to start your research. So that becomes a highest important tool, I can say, highest important. Got it? So if I am saying highest important, you have to take it very seriously. So I am stopping my lecture over here. Now I am going to take the attendance.